All right, you ready for this?
Ready.
Hi everyone, Tom Salemi here from DeviceTalks. Great to have you back on the DeviceTalks Weekly Podcast. Our episode today will focus on our one of our other keynotes at DeviceTalks Boston. I had the chance to speak with the leaders of CMR Surgical, which of course is the creator of the Versius robot. I talked with CEO Supratim Bose and Chief Technology Officer Luke Hares and Mark Slack, who is the Chief Medical Officer. Mark and Luke co-founded the company. We'll talk about what led them to create the company, what brought them together. And Supratim has had a long career in the medical device industry, so we'll draw from that and get a better understanding of how CMR is looking to change the surgical suite. So Versius is a cool little robot. We'll talk about that as well. Again, this was our opening keynote of day 2 at DeviceTalks Boston, and this will be the final keynote from DeviceTalks Boston. We couldn't bring you these interviews without the support of our sponsors, so it's my pleasure to bring in this episode's sponsor, Qt Group. I'm speaking with John Howland. He is the Senior Solutions Engineer at Qt Group. John, give us a little bit about your background, and how did you find your way to Qt Group?
Sure. Well, I've been working for Qt Group for the past couple of years. Prior to this, I did come from the medical device space, worked specifically in the neurosurgical unit on the R&D team. While I was at that company, I was introduced to this company, fell in love with it, and here I am now.
That's great, John. And tell us a bit about Qt Group.
Here at Qt Group, we offer an end-to-end software development suite for projects pertaining to graphical user interfaces. You can use industry-standard design tools such as Figma or the Adobe products, pull those designs directly into our tooling, build out your back end, and ultimately deploy that to any type of hardware. Alongside of the development suite, we also have a testing suite, offering stuff like static code analysis, architecture verification, GUI testing, and code coverage. I'm really excited for how you can use both the development side of things and the testing side together to ultimately create a great product.
All right, we'll find out more about Qt Group a little later in the podcast. If you'd like to learn more right now, I suggest you go to Qt Group's website. That is qt.io. qt.io. Find out more about Qt Group. Now let's begin this conversation that I had with the executive team at CMR Surgical at our DeviceTalks Boston conference. So thank you for being part of the conversation and for informing us on your place in this growing surgical robotics world. I've been following your story from afar since, well, partly you're abroad, so they can only see it from here. But also just growing an appreciation for the different variations of surgical robotic systems, and Versius certainly qualifies. So let's pick up the story from the start. It's always a great place to start. Luke and Mark, the company's been around for 10 years. Let's turn the clock back to 2014 and give us a sense of what sparked the idea and how you two came to get together and start this company.
Certainly. So, yes, so CMR started in January 2014, so in fact we have to turn the clock back a good 18 months before that. Before CMR, I was a technical consultant, contract research and development, and the joy of that kind of work is that you get exposure to a huge number of different areas of the market, of technology, and all the rest of it. And I had the privilege to work in surgical robotics and to learn a bit about that field. And it became very clear after working in that field that there was, in fact, it seemed to me, a massive unmet need. That globally there were millions of people who were having surgical procedures. Minimal access techniques had been around for years, depending how you count, 25 plus years at that point. And yet the uptake of minimal access surgery globally was only about 50%. Mm-hmm. And you don't have to be an expert on minimal access surgery to realize that that's because it is just so technically difficult. Manual minimal access surgery, what the surgeons can do is quite extraordinary, but there aren't enough of them who can do it. And there really didn't appear to be any compelling alternative. Robotics had been around for a long time, but hadn't really moved the dial on that. And so the question that then I thought, well, I like making tools. What does the better tool for a surgeon look like? And I believed it was a robot, so we're kind of incidentally a robotics company. But I realized very quickly that there's a lot more to this than I can understand, and so I was able to reach out through Mark, and he tells that story better than I do. So I will pass that to him at this point.
Yeah, I mean, I think just to get back to the beginning, what Luke says is so absolutely true. I was a clinical academic at the University of Cambridge and taught minimal access surgery over 25 years and realized that I could not teach everybody to do it properly. And there's a very seminal paper out of the United States in 2016 which showed all the advantages of minimal access surgery, but the fact that only about 40% of people in the US were getting minimal access. Minimal access halves the complication rates, and yet still 60% of people were getting open surgery, which is pretty, and as Luke says, what was that? It's just very technically difficult to do, and not everybody can do it. And I spent most of my career inventing, and I've worked with Johnson & Johnson very productively in the past, and I've invented quite a lot of things. And everybody assumes that that's how Luke and I met. But in truth, Luke was attending a thing in England called the National Childbirth Trust with his wife. So it's antenatal classes, and they put like-minded people together. And my wife was attending antenatal classes on her own. And the woman in charge said to her, do you have a partner? And she said, no, I'm married. And she said, well, you must bring him along. And she said, believe me, you don't want him at this class. And then Luke approached my wife and said, I believe you're a surgeon. And she said, yes. And he said, I want to speak to you about robots. And she said, the wrong member of the family, the one at home, is the lunatic, is going on about robots all the time. So it was a meeting of the minds where, you had this enormous advantage of minimal access surgery, yet in the most sophisticated healthcare service in the world, the United States, people weren't getting it. And in other health services, the penetration's even lower. So that really is how, and Luke came around to my house for the first time we met in a car that shouldn't have been on the road. And we sat with pieces of paper, Diet Coke, and discussed it. And that's where the generation started, and it's been fantastic ever since.
So prior to meeting Luke, you had already identified robotics as a solution that healthcare needs?
So I thought robotics might be a solution, and I had looked into what was in existence on the market. And there were numerous things I didn't like about what was on offer: the size, the complexity, the price, and the fact that you had to change the way you did your surgery. You had different port positions and different procedural steps. And so when Luke came and we had our first meeting, I said, Luke, the things I would want are modular and small. And he said, yeah, that's what's in my head, and I can do it. And when he left, I said to my wife, the man's clearly mad. But he wasn't. And that was what I wanted. Technically, we won't go into now, but minimal access surgery is very, very difficult. If I wanted to teach you to tie a knot, it would take about 60 hours.
Wow.
If I want to teach you on the robot, it would take about 30 to 40 minutes. So, acquisition of skills, maintenance of skills, and higher surgical standards are all obtainable with the correct robot. But it's got to fit in the workflow and everything else. It's got to be affordable. It's got to be the right size. It's got to be able to be packed away when you're not using it, so your theater isn't mothballed, et cetera, et cetera.
So, Luke, was Mark your entire bit of due diligence?
Alas, not. I think... the first thing says, I think actually, in trying to sort of understand a little bit about CMR, this very close working relationship between technologist and a clinician is a culture that started right at the very, very beginning of the organization with myself and my co-founders working very closely with Mark, and it's something we continue today. But no, absolutely not. There were initial ideas. They were involved, improved, and challenged, throughout the process of getting backing for CMR, and because it's a difficult sell. The challenge of a surgical robot is that the first amount of money it makes sense to raise, or at least it was 10 years, it's probably 10 years ago, it's going to be more now, is enough to build a system to prove your ideas work. And and there's a lot of it to build, and it's got to more or less work. And so that puts it sort of £5 million away from and several years from getting started. But anyone who looks at the market and looks at the way the industry works will realize that that's only the very, very beginning. So you've got to find people who have got the imagination to understand what you're trying to achieve, and have also got the potential to be able to follow through for some very substantial later funding rounds, because you say CMR wasn't founded to invent a robot. CMR was founded to help millions of people have the right kind of surgery around the world. And to do that, you've got to build and sell, or you've got to create a business that is building and selling and supporting and training, ultimately, thousands of robots globally, and that's obviously a massive organization. So, yeah, the diligence obviously associated with that was quite considerable, and I'm pleased to say we were able to convince people that it was indeed a feasible thing to be doing.
Supratim, let's bring you into the conversation. You bring a great deal of medical device industry to the team. We can get into that in a moment. I want to get into your path into medtech in a moment, but how do you view companies like CRM? Is it a robotics company, or is it a medical device company that's working on robotics? Do you still feel as if you're at a medical device company?
Yeah, absolutely. I think what Mark and Luke said in very nice way is to understand that it is linked back to surgery in some ways was their idea. Mm-hmm. Yeah. So though you put it in a very simple way, it still drives the purpose of the company within. And that is how to make minimal access surgery available to most people. Yeah. So as I come with the experience of medtech of 4 decades, I still say I don't call it a robotic market myself. Mm-hmm. There is distinctly an ecosystem that has to be created for companies like ours. How do we reach that 90% of the patients who are not getting the benefits of robotics? So the biggest question in our mind as a leadership team is, if after 2 decades, there is a medtech which is only 10% penetrated, it has never happened before in the history of medtech as far as I know. Mm. And that's the solution we have to look for. That's what we are working for. We cannot get into discussions of this is the robotic market, this is the one product, and compare everything to it. It will never get us to where we were. So the whole organization is built understanding we are in the medtech space. We require certain capabilities to be able to do that well, R&D being one of that. That we require a great deal of focus on how to educate surgeons. Mark spoke about it. So the basic ingredients to make it work is there. But the whole thing is, how do you look at this market? And we don't want to go and say that we are in the same market as X, Y, and Z. We go to say that there is 90% of people who still do not get this benefit. So our model created, our business model created, the segments we have created are so different. Yeah. So if we have whatever installations we have, and that we are in the markets where we are in the number 2 position is because of that. We don't have a standardized business model. We have to say, how do I enter this market? What is our strategy for it? And within that market, how do I go to different accounts again completely? So our entire field force and commercial have a completely different mindset, completely. There is no standardized approach to say, except to say, how will more and more patients get the benefits? Yeah. So in some ways it is linked. Yep. Because the capabilities needed are not different. The robotic is a capital equipment, so the commercial sales cycle and all that is different.
How about the culture? Does it feel like a medical device company or more like a technology company?
I think because the idea came out of Luke, Mark, and the earlier founders.
Yep.
almost everybody you speak to have a great mindset on technology, different from every company I've worked with. So secondly, it is a small team. They are all there. So almost everybody is going through R&D. Everybody is going to the technology.
It's a startup mode. I mean, it's a very similar formula
right.
for many startups, medical device startups.
Yeah,
You've
exactly.
got the engineer and the doctor. So.
Exactly. So even though now we are in the growth stage, that culture exists.
Yep.
So technically, very, very sound, and ability to understand customer needs is very, very high. The Luke and the team are continuously finding out ways to listen and change. We have each version coming up as we look into the future. Luke can talk about it. Yes.
The mission is extremely important. Obviously, as we've got larger and larger, the R&D team is now less than a quarter of the company. That's exactly how it should be. But even at the very, very beginning, yes, we know we're trying to do something very technically challenging. We know we're trying to do it very fast, classical technology startup. Yes, but also no, in the sense that the reason, or one of the big reasons, we were able to attract so many good people to CMR in such a competitive environment for that kind of talent as Cambridge, UK, is because of that very strong mission that this is about using these technical skills to create a product that has the potential to really make life better for millions of people a year. We've pulled people out of Amazon, we've pulled people out of Microsoft because actually they would rather not use their talents developing algorithms to sell more coffee machines. There is a genuine and massive privilege. I've felt it, many of my engineers have said the same. When you're going into the OR, you're seeing the thing that you created, and for the person on the operating table, it's one of the most important days of their life, and you're an integral part of that. And you want to see what you're doing, and then work out how you can do it even better. And that's a massive privilege. That is not a technology company privilege. That's a medical device company privilege.
Sounds like a medical device company.
And that's something which is very important to all of us.
I mean, Supratim always makes a comment which really resonates with me, is that it's a great honor and a privilege to work in medtech and actually do something for a population. But, just building the robot wasn't enough. You've got to surround it with all the components that make it a safe proposition. So the company has been incredibly supportive of doing a very refined research program, which is an innovative one that we've done called IDEAL, which is probably the way forward for medtech rather than for pharma. We've also had a very innovative professional education program, because I know he's building a robot if the people that are using it aren't properly trained. And in the 90s, when minimal access surgery came into the world, many thousands of people were injured because the medical community was a little bit rash and went at it a bit fast. So as a company, we've been very responsible and created a real training program which got VR headsets and metrics to measure performance against, so that our introduction, and then just to put the cherry on the top, we have a registry, so all the people operated on get entered into it. So if I know if a person has had a complication in surgery, I know about that. Or if a person's died in surgery, I know about that. And then that goes to a committee external to our company who look at the videos and see whether it's anything to do with the robot. And that's the sort of level of responsibility which exists through the company, supported from the top down, to be mature and actually remembering at the end of the day it's about the patient on the table that really counts.
That's great.
All right, let us take a quick break from this conversation and bring back our sponsor, Qt Group. I am speaking with John Howland. John's Senior Solutions Engineer at Qt Group. John, earlier you mentioned architecture verification. I'll be honest, I don't know what that is. Could you tell me a bit about architecture verification and what are the benefits?
I would argue that the architecture of the application of your software is one of the more important pieces of the project. Typically, the architecture design is designed by a team of maybe specifically software architects or senior engineers inside of the company. And ultimately, that design needs to be followed by all members of that team. There was a study performed by a team at IBM, and they essentially concluded that a bug found post-production, in a released piece of software, can be up to 100 times as expensive as if that same bug were found earlier in the development phase. The goal is to make sure that the architecture that was designed by that team is being followed by all members of that team to avoid rewriting code, throwing out code, creating a too complex of an application, adding too much technical debt. We're trying to mitigate that. We're trying to make sure that that doesn't happen.
So it's about safety. So how does architecture verification help ensure safety in medical devices?
Let's relate this to building a house really quickly. Builders have blueprints that they use to know where critical infrastructures within the house are. Something like where a load-bearing wall is. The architecture, that design was created by an architect, and then it's the builder's job and the subcontractor's job to follow that intended design. The same concept is true in the software realm as well. All members of that team have to make sure that they're following that intended design as they're creating code, as they're pushing code into the repository. In both cases, the architects are thinking about both the current state of the home or project, as well as the future of that home/project. Something like in the builder's perspective, they're making sure that a wall is designed in a particular way so that you could potentially expand. On the software realm, an architect might build a specific module so that it's very easy to add additional features into it. Diverging from this intended design, can add increased bugs, can add technical debt, make it so that features can't be added easily. It's just not going to be very sustainable if that intended design isn't followed.
I see. Finally, John, how can Qt Group help?
Here at Qt Group, we have the ability to verify that the intended architecture is being followed by all members of the team automatically. We have a static analysis tool called Exivian, and it has this built into it automatically. No more are you having to look at your source code and look at a drawing of the architecture and like PowerPoints and wondering whether or not you're compliant with that. Let Exivian do this for you. We can be built directly into your pipelines, into your natural processes. Each developer can, as they're writing their code, they can be confident that they're compliant with the intended architecture by using our tool. If they are diverging from the architecture, we can let them know directly what line number that they're diverging from. Spend your time more wisely. Don't waste your time doing the things that our tool can do for you. Spend the time doing what you love.
All right, that's great stuff. Thanks again, John Howland, Senior Solutions Engineer at Qt Group. Thanks to Qt Group for sponsoring this episode of the DeviceTalks Weekly Podcast. If you'd like to find out more information about Qt Group, go to its website, qt.io. Now let's get back to this conversation.
Supratim, let's talk a bit about your career just a bit. What brought you into medtech? And talk a bit about where you spent your time, because I think it's an important part of this story, the fact that it's a company that is a medical device company, we'll say, that's focused on robotics, but now has a leader who is bringing decades of medical device experience.
So, Tom, I've spent over 4 decades in the medtech business itself, and I've been through almost every business segment that you can think of in this, because I was working with J&J, and I was in charge of the umbrella organizations in the emerging market. So we managed every business, not only one BU, but all the BUs. Then I had the opportunity to look at and talk with Mr. Mike Mooney, who wanted me to join there. So I got into, after 30 years in J&J, went into Boston at a very critical juncture at that time. Yeah, so we are talking 2010 and 11, which everybody knows the history. And again, there was a learning there which was brought in, which helped to understand again that in the medtech world there are certain capabilities and competencies you have to build. Most important of that being talent. Yeah, so if I put one common factor across every organization, is that simple philosophy used for 4 decades: grow people, grow business. You cannot think of anything else, because the R&D person is developing the product. The others are trying to help in that way to market. So that experience was, again, very helpful. Completely new businesses, different businesses, some of it. and there were learnings from it. But all through being in medtech was always interested in what is happening around. And obviously, like I said, never had experience or thought it could happen, that could be a market which is there for over 2 decades with a single product. Yeah. And that was the part which kept me involved in understanding robotics. Also for people who worked in J&J, some of the first units we had seen of that product was actually in our Cincinnati training center of Ethicon Endosurgery. So there was exposure to it, there was understanding about it, and the fact that this market keeps growing all over the world, wherever they are and wherever we are present. When this thing came up, I joined as an advisor actually.
Okay.
And to advise. And it was evident there were things that could be done. And then somebody said, can you run the company? So I took some time to decide, then thought, hey, let's help, because I met Luke and Mark and their story was very inspiring. Yeah. So I think the opportunity exists to create a segment and an ecosystem which will address all segments of the market which go finally to help the patient. So we are in emerging markets for the first time. Many of our markets are doing robotic surgery for the first time in their life. There are hospitals, many of them, maybe 50% of our installations, where surgeons are doing robotic surgery for the first time. And thanks to Mark, we have developed a training program which is so good. It takes time, it takes effort, but that's what we look forward to. Yeah? So I think that excitement of creating an opportunity for a unique product that Luke talked about in his very nice way. But when you go through the steps of how this was thought through, it's very amazing. Yeah, it was on a sheet of paper, he drew it. There is a wooden arm, which is there in all our company. He actually cut out himself a wooden arm to show how the arm would look in his garage, which is fascinating to hear. So when you talk of innovation, and I've been through 3 different companies, I've seen the R&D people. But if you look at that arm, you'll know what went into his mind. If you listen to his story on why he thought about it, and when he saw the first of the other product displayed somewhere, and he said, I can make this more simple for sure. Yeah. So that interest is what I think we have to continue to develop, an innovation that will help more patients. I think that culture they have created is very unique. To me, that's the best part of being here. That, like you said, even anybody you talk to, they know this is finally what we are looking at.
Yep.
And they almost avoid getting into a discussion of this giant. They almost avoid. They say, we don't even want to look at that ecosystem. It is a separate ecosystem. And for us to try and go there, but though we have almost 30 installations in previous users of the other system, we actually have in our installation. But it has come because of that focus. Mm-hmm. New specialties, who almost never had access to it. Smaller hospitals, mid-sized hospitals, which could have never got it. And so that's the approach we have taken, to address that and create an ecosystem separate for Versius and not too much worry about what is being discussed with the others. While technologically he is keeping ahead, mentally. How to compete technically, prove the science, both of these people are smart at that. Yeah.
Well, if you have a garage and a device in a garage that qualifies as a medtech startup, you needed to have the garage. Now you checked all the boxes, so that's great. Let's introduce everyone to Versius. Mark, let's talk about, Luke, let's talk first a bit about the system itself. We don't have an image of it, but give us just a sense of its look and feel and
yes,
and
certainly.
What its function is.
So Versius is a laparoscopic telepresence surgical robotic system. It does all the things that you would expect such a system to do, which is critically it provides the surgeon with stereo vision from an endoscope they control. It provides fully wristed instruments. That's very important, of course, for duplicating the dexterity of a human surgeon, but inside the patient. And it does all the frame of reference transformations. And just to make it clear what I mean by that, it means that when you're looking at the screen and you move your hands on the controls, up, down, left, right, and move your wrists to change the orientation, the instruments move in the same way. And the combination of all those things means that we achieve one of the things that I think is the most important, which is that when the surgeon is using the system, it is effectively transparent. Once they've mastered the controls, which are designed to be as straightforward as possible, all they're thinking about doing is, I just want the tips to do this, and their muscle memory and their hands look after everything else. And the consequence of that is you really can give the system to an 8-year-old and they can start tying knots. I've seen them do it, and that's what you want to aspire to. So that's the sort of surgeon experience, which is what you would expect. The area where we are substantially different, I think, from the vast majority of systems that are out there is once you get to the bedside. And it's once you get to the bedside you realize that actually we haven't got the kind of sort of large support structures with remote center of motion mechanisms hanging off them, which describes the majority of the surgical robots out there. What we have is a number of small, lightweight, collaborative robot arms that are holding the instruments or which are holding the endoscope. And the realization that was really the key to Versius was recognizing that if we designed the wrist on those robot arms differently from the wrist on all industrial robots, then we would be able to achieve the kind of range of motion necessary to do surgery, but with a very small robot arm. And that was important because you can't really fit bigger robot arms around a patient. And we combine that with the very sophisticated collaborative robotics, which makes the setting up, tearing down, and moving around of these arms a straightforward exercise, because the clinicians around the bedside are extremely talented clinicians, but they're not robotic technicians, and it's not reasonable to expect them to. And that then brings us back to the essential premise of Versius, which is that we felt that if we put together a system that could physically be set up to do the overwhelming majority of laparoscopic surgery, and which critically could be set up to do it in the way that surgeons were used to doing it, so they simply needed to learn the tool, not a new kind of procedure, make it as straightforward as possible for the bedside staff to learn how to set it up, tear it down, move it around, make it so that it fitted into existing OR workflows by being movable, by being able to be pushed to the side, up and down lifts, through doors, all that kind of thing. If you could achieve that, you'd have a system where there were lots of people who could drive it, and it could do everything. At that point, you can keep it busy. We want all our systems to be as busy as the hospital can make them, and if you can keep them busy, you can transform the economics, and then suddenly everyone can have one. And that was the basic premise that we worked out 10, 11 years ago, and it remains the core of what we're doing now. And I think it's as valid an approach now as it was then. Just as then the market was, roughly speaking, 10% penetration of robotics. Now, it's roughly speaking 10% penetration of robotics. The big problem we set out to solve, and which we think we have a solution for, is still there.
I want to explore the modularity in a moment and where it fits in the clinical setting. But Mark, let's just talk a bit about where it's available commercially and where it has regulatory approval, and talk a bit about that process.
Yeah, I mean, it's obviously, I harbor some reservations about some of the regulatory processes around the world. But we have regulation.
This is being recorded, so. And will be podcast, so have at it.
We are present in most of the Middle East and Asia, Africa, South America, and the whole of Europe and Australia. So we have a very wide penetration, and that is in everything from large, sophisticated teaching hospitals, which are ranked in the highest, in the biggest teaching hospital in the United Kingdom, and one of the most famous in the world, has our system. And we've also got it in very small hospitals and private hospitals with much smaller footprints elsewhere. And that, I think, again, is, as Luke was saying, that shows that we can actually are valuable across a range. The other important thing to remember is that we can operate everywhere from the chest via all the aspects of the abdomen, colorectal, upper GI, bariatric, urology, gynecology, etc. And we operate from the simplest procedures, like an appendicectomy, to the most complex procedures, like an esophagectomy or pancreatectomy. They don't get more complex than that. And we actually have a series of about 68 esophagectomies done with the robot. And, there was a comment made by someone, I can't remember, that ours was a little bit, like a simple robot or a toy that would do minor procedures. It so is not a toy, because it actually does the most complex procedures. And we underpin that all with published research to support what we say about the program. Because again, it gets back to this whole thing. It's no use building a clever piece of equipment if you do it irresponsibly. And if we found out we weren't as good in an area, I would stop doing it. Mm-hmm. And, a good example is a paper was done here in the United States by a very eminent chap from Johns Hopkins called Pedro Ramirez. And he actually showed that laparoscopic surgery is not as good for early stage cervical cancer as open surgery. So as a company, we said, fine, our robot will not be used for early stage cervical cancer. We follow the evidence and we do what's correct. What we are starting to show for the first time, and if you had asked me 5 years ago, is robotic surgery better than a good laparoscopic surgeon? I would have said probably not, because good laparoscopic surgeons are very good. We are starting to see glimmers and evidence that robotic surgery may actually confer advantages in the surgery you're doing. And then more importantly, and I'll give you a personal note on this, is I've been getting some terrible right shoulder pain over the last couple of months. And I went to see the orthopedic surgeon, and he said, you're not very bright. I said, why is that? He said, well, you've been doing laparoscopic surgery for 25 years, and you have a laparoscopic injury. And ergonomic injuries are shortening careers of surgeons all around the world. And when you spend all that money training them and all that money maintaining them, what you don't want is somebody taking premature retirement because of an injury. And on the robot, you're sitting neutrally, you're facing straight ahead, your neck is in the upright position, you can stand if you wish as well. Whereas in minimal access surgery, your arms are out on the side and you're in horrible, uncomfortable postures for hours. So those are all peripheral clinical benefits that people don't think about.
Supratim, Mark brought up the suggestion that Versius is a toy. Let's talk. A CEO suggested it was a toy. Let's just talk about Versius' place in history, in the industry rather. What's the source of criticism for that, and how do you respond to that as a CEO?
Yeah, again, I go back to the clinical aspects of it and the science of it. Yeah. So the first thing is, if you can do these complex procedures, it has to be a very good robot that can assist a surgeon to do the surgery properly. Yeah. So when you talk of complex surgical procedures, most of them are being done. 2, it is across specialties. Mm-hmm. Yeah. So we have 133 different procedures done across specialty, different ones. 3, there is a registry for every procedure. So it's one of the unique things that everything being done is recorded and kept. And like Mark says, if he notices something which raises concern, then we have an ethics group, etc., to go back to. So if you see the complexity of the procedures being done, it can never be done by a simple something that is a toy. It's not possible, right? So your configuration need not be that complicated to be able to explain that I'm a more effective robot. The thing is, can you do the procedures? I think the next part of it, it is done in some of the best teaching hospitals in the markets we operate in. Yeah, so these are literally very experienced laparoscopists, like Mark said, who have spent years and years and still. So the next point is that referral of Versius is in some of the best teaching institutions. And most of the people who have used it understand it. But at the same time, like Luke said, we continue to look at how to improve. So is it perfect yet? No. So Luke will tell the story, Mark will tell. So the whole focus is keep improving, keep improving. So as we have Versius 2 version and the later ones, our digital capability, again, cannot come out of just being a toy. It's not possible. It's perhaps the best one we know of available in the marketplace today. We have to know how to deploy it better. So if you look at everything, first patient, then you look at the surgeon, then you look at the accounts where we are, you look at the markets where we operate, it is accepted almost in all of the segments that you would like a robot to be used. And so I think that proves the versatility part of it. And the modularity of it is also the part, like I said, we are creating a segment which I don't even want to call a robotic market. So there are surgeons who used to do 5 procedures, have done 10 to 12, because they're prepping patients into operating room and moving our robot. Then our robot is being moved from one specialty to another depending on the hospital procedure, calendar and schedule, which can never be done otherwise. So all put together, it's a versatile and clinically proven system.
Mark, do you want to say something about that?
I'd just pick up the point on modularity. I mean, modularity is nice, but you've got to ask why modularity. I mean, it's a design feature. It doesn't have any clinical benefit intrinsic to itself, and I'm very resistant to design features that don't have clinical benefits. In our case, it is to support the versatility. One of the things that I'm very proud of, and which I think, again, goes a long way to proving that we got the basic design of Versius correct, is that over 50% of our systems are being used by more than 4 specialties. And that's exactly what we need to achieve.
What does it say? That it's easy to use, that it's just versatile in how it's...
It speaks to the versatility. It speaks to the fact that because everything is on its own base, you can put it where it needs to be, but because those bases are small and compact, you've got that enormous range of options as to where you put things. And there are, let's be clear here, there are some challenges associated with that. A very multifunctional tool is a bit more difficult to learn how to use than a tool you can only use in one way for one thing. Mark's Prof Ed's programs and our implementation team are very good at solving those problems. But once you've got that understanding, suddenly you realize actually you can set up Versius to do the procedure you want to do in the way that you want to do it. And personally, you then get to a very, very exciting stage where you start to think, hang on, if I move that over there a bit, or I put that port there, I can start to do this procedure in ways that are physically not possible for me to do them. And we are already seeing clinicians, some of our advanced users, taking on procedures in ways and using Versius in ways that we frankly had not imagined that they would use. And that again I think speaks to the versatility that we get from the modularity.
Mark, help me understand from a physician's perspective how Versius fits into the clinical setting. How would it be brought into an OR? How would it be removed? Sort of, how does it fit into the entire workflow?
I mean, that's the massive advantage of it. If you're not using it, it can stand against the wall in the theatre, and the theatre is still totally usable. And then the minute you want it, it's wheeled across, and you can put it in place. You can drape the patient, the patient, drape them, and drape the arms of the robot in about 7 minutes. So that's, there's no workflow interruption. Mm-hmm. It also provides the ability for a surgeon to do the entire procedure with the robot, or if they so choose, they can do parts laparoscopically as well, if they are a laparoscopic surgeon. And there may be areas where that may speed up things or generally help. Because we've got it all on data, and we are obsessed with data as well, I use a thing called control method analysis to measure the use of it. So we plot people against funnel plots and QSIMs. So I can tell you now that if a surgeon is a laparoscopic surgeon and they want to adopt our robot, it takes roughly 10 to 14 cases to get them to the stage they were at as an expert laparoscopist, which is an extraordinary, and that's not a guess, that's measured and will be published. And so it just fits into your flow. You don't have to alter your theatre. You don't have to adjust your lights. You don't have to take the doors down to get it in. And you don't have the theatre standing idle when it's not being used. And of course, the clinical side is also, Tom, the most exciting one. Just to give something that the audience will really resonate with. Because the way Luke's designed it, when the instrument goes through the abdomen, at the point it goes through, it doesn't exert any lateral pressure on the skin. And that massively reduces pain control. And we have patients that virtually no longer need any form of opiate analgesia after a major laparoscopic operation because of the robot. Now, in the US, 9 to 12% of patients who undergo surgery are still using opiates 12 months later.
No.
So something that avoids opiates is a real advantage. And I'm going to be very careful here, but in some of our experimental work, the veterinarians have noticed that the animals operated on by the robot have less pain and discomfort than those operated on by laparoscopy, and they can't distinguish between a robot and normal. So that's a very exciting, tiny clinical bit that robots will be better, and we're starting to see other areas where you almost certainly couldn't do the surgery with manual laparoscopy, but you can do it with the robot, like through the mouth. So I'm going to shock, so I apologize to the commercial people, but if you've got throat cancer, some of them, they have to split your entire face to do the operation. And now with robotic surgery, it can be done through the mouth, therefore not disfiguring a person and getting an equivalent result. So I hope that within 2 or 3 years' time, I will start producing the papers that show the advantage, not just the equivalence, not just the increase in minimal access surgery, but the advantages of robotic surgery over laparoscopic surgery.
Luke, let's talk about new technologies. We're seeing with other systems the use of data, AI, VR, AR. Is this part of Versius's future as well?
I think so. The Versius system continues to evolve and improve. We've recently released ICG. Our advanced energy instruments are coming to market. We have an ever-increasing range of the basic instruments as well. But the really exciting thing, I think, that the Versius architecture enables, and it also speaks to the point Mark was making about data, is Versius, as I said, the big thing that's different about us is that we have these fully flexible robot arms. And there's a cost to that, and that cost is a lot in software complexity. But there are enormous benefits. And the key enormous benefit is that at a very fundamental and basic level, the behavior of the system is controlled by software. So the advantages around the location of the surgical port Mark talks about, I personally believe, haven't yet managed to prove, but I personally believe that a lot of that comes from the fact that when you're setting up Versius, you rely on the system to find the natural pivot point of where, so you've put the port in. We don't, unlike many systems, kind of bolt the patient to the robot. We don't attach the port to the robot arm. Instead, what we do is we let the robot arm find the natural pivot point of the instrument by inserting the instrument just into the port and then moving the robot around. That obviously makes a cone, and the tip of that cone is the natural pivot point of the instrument. It's the point at which it moves with this least amount of resistance. Once it's found it then holds it for the rest of the procedure with great accuracy. And that's an example of this very sophisticated robotics, but that behavior is under software control. And so as we learn from the 160 or so plus systems we have out there with our clinical data and our telemetry data, we can take that learning and we can use it to update the fundamental behavior of the system. We are a software-defined system, so and then we can roll it out to every system that's out there so everyone can benefit from it. No need for new hardware, simply a software update. And so I think we'll see more and more and more of that as we learn from the background, and then we can turn that into actually changes as to how the system works. The other thing, of course, that we're doing is Versius was designed from the very start to be part of a larger digital ecosystem. This is why we have these data pipes and things. And we're now also building out that ecosystem. We have an increasing range of apps providing ever more information. So the big way, we are surgeons to fill in the registry. One of the reasons they like to do that is because Mark and his team, via the apps, are then able to provide them with useful information that they can learn from. As I've said before, every surgeon that I've met would like to serve their patients better. The thing that will enable them to do that is information that they can learn from. And with Versius, we're not only gathering the clinical data and the outcomes, but we're able to correlate that with insights into their procedure, provided from their video, provided from the telemetry feed, and to give them that feedback pretty much real time. And we're just right at the very beginning of that transformation. You have to have a solid robotic platform in order to be able to do that. But then what you're going to do with that is going to stretch into the future. It's going to be a long journey. It's not going to be like turn up on Thursday, ta-da, automatic surgery. But you need to find the route forward, which every step you make is providing benefits to the surgeon and to the patient, and I'm confident we can do that.
And I mean, Tom, there's early glimmers of that. Luke mentioned the telemetry. If we look at the telemetry feed of the movement of the instruments and the movement of the surgeon's hands, with a 99.9% accuracy, we can tell the difference between an experienced surgeon and a novice surgeon. And that's just got huge implications for training in the future and for monitoring of skills. Wow. We took 8 of each, 8 novices, 8 experienced, and the system identified 7 out of 8 in each. So we then looked at the videos, and the one novice was fairly talented, and the one expert wasn't. So it just gives you an idea about an objectivity thrown into training, which has massive international implications.
And that's the kind of thing that's led to us being able to move to proficiency-based training. So rather than just simply require the surgeon, the surgical team to practice with the system for a set amount of time, yes, good, off you go, you're actually able to test them, and if they achieve that in a few hours, great. If it takes them a few days, then it takes them a few days.
We see that some learn it in 2 hours and some take a bit longer, but at least we know that the end product trained is actually going to do a good job on the patient that they're looking after.
Part of that is also the VR-based training we offer. So we've always had a simulator for the system. A small box comes with the system that you can plug into the console, and it will provide you with a simulated environment for training tasks. Mark's team, working with my team, have been able to migrate that to some of the sort of portable VR headsets that are available. So in fact, anyone can take home the simulator with them to home to practice there. And we've also been able to provide VR-based team training. So if you want to know how to set the system up, how to position it, how to handle the arms, you can learn all of that in VR in the comfort of your home before you come in to the training programs with Versius. And that, again, is essential because we're not interested in selling a few robots. I want to sell a robot. I want that hospital to have a fantastically successful robotic program, which is only going to happen if they've got people who know how to use it, and which they can get the volumes up and it can really make a difference. And then I want them to buy another 5, because that's the scale that this thing has actually got to work in order to achieve what we're setting out to achieve.
Great. Well, we have only a few more minutes, so let's just quick look to the future. Supratim, how does the surgical robotics industry play out? We're seeing a number of companies getting different types of regulatory approval. We're seeing a move away from the sort of traditional larger systems. We're talking about the more modular systems like yours. Where does CMR fit in the future, and what does the future of the surgical robotics industry look like to you?
I think from every indication you get from the market, from the physicians, from the healthcare providers, the robotic market will continue to grow at the pace it is growing today. Yeah? Every projection indicates that it may probably even increase as you get into the emerging markets to accept it even more than it is today. Yeah? So the market-wise, it will. I think the second part of it is to see again how this market will be segmented. Yeah? So the workflow becomes very, very important part of it. The size and the procedures that can be done with the robots becomes a very important part of the decision-making process. So I think every one of those robots will have a place in some ways if they are resilient and can sustain what they are doing. Yeah? So the whole thing is, like we started with, the entry into this market and being sustainable over a period of time will require that resilience, and obviously you must have the cash to be able to support this business for the long term. Yeah? So if I look into the long term, that penetration has to increase. It cannot remain at 10%. It never will be. And for us to be able to do that, therefore, it is important to find out what each of the surgeons or specialties in each of the markets adapt to. Yeah. So if all those robots will have their own place, if they continue to be there, similar to ours. Yeah. So we believe that the market will continue to look positive, and as we get into the newer markets, we will continue to have to find business models which suit that market, like I started from the beginning, and that is the reason for our success till now. So whatever the 172 or more installations done, and the utilization is, our growth is significantly higher than whatever the normal market growths are. We see that same thing in the first 4 months here. So the utilization rates are high. That indicates what Mark was trying to say. As people get used to it, it will become a part of the system. The most important thing uniquely we are seeing is that certain governments are propagating the use of robots in certain cases. Yeah. So, and that is a good positive part. A big part of the low penetration obviously was the overall cost of acquisition, yeah, and trying to get the procedures to be affordable to patients. I think we are addressing it better than most others, and that is another reason why we believe the penetration will increase further.
All right, great. Well, we've got 51 seconds left. That's enough time for applause. Thanks very much for being here.
All right, well, that is a wrap. Thanks so much for joining us on this episode of the DeviceTalks Weekly Podcast. We'll be back next week with another episode of the DeviceTalks Weekly Podcast. We launched this week a new podcast, DeviceTalks AI. I referenced it in the podcast last week. It did go out featuring Ha Hong from Medtronic. He was actually a speaker at DeviceTalks Boston as well. So if you're not a subscriber to the DeviceTalks Podcast Network, you can find that episode of DeviceTalks AI on DeviceTalks.com, where you can find the rest of our DeviceTalks podcasts as well. But it's much easier just to subscribe to the DeviceTalks Podcast Network. So please do that. Please also connect with me on LinkedIn. It's always great to connect with folks who say they're listeners of the podcast. It's always a treat. So if you're listening and you appreciate the podcast, please do connect with me on LinkedIn. Also, connect with Kayleen Brown, managing editor of Device Talks, and of course, Chris Newmarker, executive editor at Mass Device. Chris will be back on Device Talks Weekly in a couple of weeks. We're just working on some new format changes, and it's going to be some exciting new stuff. So we'll be bringing you that shortly. Other than that, please continue to go to or register for our Device Talks Tuesdays digital meetings. We'll be meeting again on Tuesday at 4 p.m. after the Memorial Day weekend. So take a look at DeviceTalks.com for information on our upcoming sessions. Those are free, and you can watch them live or on demand. Either way, you can ask questions of our MedTech experts. So it's a great opportunity for you to expand your skill set. All right. Well, once again, thanks for joining us on the Device Talks Weekly Podcast. I'm recording this on the Friday before Memorial Day. I hope you're having a good long weekend. For those who lost loved ones in the service of our country, thank you for your sacrifice, and I hope you find some peace and fond memories this weekend. And we'll be back again next week on the Device Talks Weekly Podcast.